Hi, welcome back. This is Nick Agriam. In this series of videos, maybe in this video, I will be discussing transforming functions. And I decided that I'm going to give explanation of this topic by giving you an example. And let's see what happened. And I'm going to use GeoGebra to illustrate my example. For example, we have, as you can see here, f of x is equal to x squared. That is the graph of that. What happened if I'm going to add 3 to the function f of x? That means x squared plus 3. What happened to it? Then let's see what happened. As you can see, it transformed the graph of the function x squared 3 steps higher in the y-axis. Okay, so that means when you add a function, add a constant to the function, then it is always on the vertical axis. It will change only the vertical axis. Okay, let's see if we subtract minus 1. And you can see that we have minus 1 there. Okay, 1 step downward. Okay, what happened if I'm not going to add to the function? I am going to add to the x of the function. For example, we have the I sub x here. We have x plus 2 parenthesis squared. That means our f of x, as you can see here, is still the orange one. What happened if I'm going to add 2 to that? Then we have, it will transform 2 steps, because if the positive 2 there, or plus 2 there, I'm going to explain later. If it's plus 2, then you have 2 steps to the left. If it's minus 3 there, then it is 3 steps to the right. Okay, what happened if I'm going to combine these two? Adding and subtracting for the f of x, and then I'm going to add or subtract for the x. So let's see what happened. As you can see here, when we said that if it's minus, as you can see here, minus, that is 3 steps to the right. And then if we have minus there, then it go down. I'm going to remove those. So that means I am expecting that I'm going to transform my f of x 1 step to the right and 3 steps to the left. To the downwards, I guess. I should have said. Okay, 1 to the left there, as you can see, my cursor, and then 1, 2, 3. Okay, and for the next one, I supposed to have 2 to the left for the x-axis, and then 1 upward. Let's see if that's right. Sorry, I took the wrong one. This one. So 2 to the left, and then 1 upward. Okay, let's see the third one. It should be 3 to the right and 2 upwards. Okay, 3 to the right and 2 upwards. And this one, it should be 2 to the left and 1 downwards. 2 to the left and 1 downwards. Okay, there is also what we call, before I'm going further for the next 2, because it is called stretches for the next 2. If I'm going to summarize what I have said, it says here, for y is equal to f of x plus b, a constant. B is a constant. This one is a constant. The effect of b is to translate the graph vertically through b units. If b is greater than 0, it moves upwards. But if b is less than 0, it moves downwards. As you can see, if I'm going to repeat my example here. If it's greater than 0, it moves upwards 3 steps. If it's less than 0, then it moves downwards 1 step in our example. Okay, the next one. If y is equal to f of x minus 1, the effect of a is to translate the graph horizontally, that means in the y and the x-axis, through a units. If a is greater than 0, it moves to the right. That means x minus, it should look like this. This means this is a is greater than 0 because here. The other one is when it looks like this. When you have plus there, that means your a is less than 0. When you have minus there, that means your a is greater than 0. So if you have a greater than 0, that means you have x minus a, it moves to the right. But if your a is less than 0, it moves to the left. That means x plus a. Let's go back to our example here. We have x minus a, x minus a. We expect, and x plus a, we go back here. If it's x plus a, then we need to the left. And if x plus x minus a, to the right. Let's see. Let's go back here. X plus 2, that means to the left. And x minus 3, that means to the right. And then let's see one more time the explanation here. So if we have x minus a, that is right. X plus a, that is left. So we expect that we have, if I'm going to remove that once again, our a here is minus 0, and that means that we have to the left, this one, that one, 2 steps to the left, and this one is 2 steps to the right. Combining those two, I have now my examples here for k, l, m, n. Combining those two, that means this one to the right, this one to the right, because it is minus 1, and then downwards. So I am expecting that, let's see if I can find my pen here. Yes, I have pen. I am expecting that this one is to the right, this one is supposed to be here, and then 3 downwards. 1, 2, 3. So it should be like that. Let's see if that's what they said. Okay, good. And this, the other one is we have 2, x plus 2, that means to the left, and 1 up. That means here, and then 1 up. So this one is our. Let's see if that's all right. Okay. Next, we have to the right, because it's x minus 3 here. And then plus 2. So to the right, 3 steps to the right, 1, 2, 3, and then up, 1, 2, and it should be there. Okay, and this one is to the left, and then downwards here. There you go. Okay, and then there is what we call reflections. That is what I'm going to show you with function O and function P. Let's remove everything here. Okay, let's see what happened if we have negative. I'm sorry, I'm going to remove that also. I'm going to use this one. That is my function right now. What happened if I'm going to put a negative outside the parentheses? Let's see. As you can see, it reflects the function I sub x, the blue one, with the x-axis. Okay, it reflects with the x-axis. Okay, so the x-axis is your mirror, if you can think like that. Okay, and then let's see what happened if I'm going to put just the negative in the x value. Let's see. Then it reflects to the y-axis. So y-axis is your mirror this time. Okay, here's the rule. It says here, for y is equal to negative, that means your negative is outside the value of x, like what we did here with the O. Our negative is outside the parentheses. It says here, we reflect y f of x in the x-axis. So our mirror is the x-axis. But if we put the negative in x, then we have the reflection is with the y-axis. It says this. We reflect y's f of x in the y-axis. So I hope you learned something from this video. I said series of video, but I guess it's enough for one video. It's almost 12 minutes. It's enough. And in my next video, I will be discussing sequences and series, or series and sequences. So I hope you learned something, as I've said. And thank you for watching. And if you like what I am doing, please like it or subscribe. And see you next time. Have a nice day.